Okay. Hello everyone. Can you hear me okay? Great. Thank you. My name's Simon Monk, and the title of this presentation is How to Get Started in Electronics. And I've given quite a few talks here, generally about very specific topics, so it's been about a particular board or a particular way of new technology that's come along, like FPGAs and things. And it sort of struck me that really what would be useful for people getting started is a bit of an overview of what options are available, because I think the way that people do electronics has changed a little over the years. So I'm an author. I write full-time. I write books about electronics for the maker movement. So I have some books on the Arduino and the Raspberry Pi, and I have a new book that's just coming out next month on the BBC microbits, programming the BBC microbits using MicroPython. I'm hearing an awful lot of interest about the microbit here, which is good to see. I also have a secondary role where I design a few products for a business that I have with my wife, making kits to accompany the book. Because one of the problems with selling books is people come back to you and they say, where do we buy the parts from? So we kind of put together parts and sell them on in kits as well to accompany the books. Okay. So I'll just get rid of this little dialogue. Just noticed it. Didn't mean it to do that, sorry about that. Okay, so apologise for this, it's not moving me on. I apologise for this. For some reason my keyboard is just not doing anything. I think it's just frozen. Let me just Oh, what did you do then? Was that me? Okay, it's going again. I apologize. I don't know what happened there. Don't usually have this problem with Macs, but I think we're good now. I think it's going. So making electronics, it used to be how it is on the top there. So you'd have a circuit diagram, and you'd have a chip like the famous 555 timer IC, and then you'd connect everything together, solder it up onto some kind of strip board or other prototyping technology, or make your own circuit board and attach it to it. But the whole point was you were making a circuit just to do one thing, and you had to learn quite a lot of electronics to really do that. But now the way people get into electronics in a maker way is that they go ahead and just buy ready-made modules. So you have a little 7-segment display module, and you connect it to a board like the Raspberry Pi or the Arduino or one of these other boards. So it's kind of changed a bit how people do things. And I think quite often, once they've started building things connected to boards, they may then go back and sort of backfill with the theory about how you actually do the real nitty-gritty electronics. And I suppose this is the distinction is between out-and-out hardware or using software in combination with hardware. So if you're blinking an LED on and off, you can use just a hardware timer chip like the 555, but it can't do anything else. And the upside of that is you don't have to do any programming. So if programming isn't your thing, you can just buy the chip that makes an LED flash and make an LED flash. But hardware is very difficult to change. So if you decide that you want your LED to actually blink Morse code at you rather than simply turn on and off, then you've got a lot more work to do. If you want to try and do that in hardware, you really can't. You start to need some intelligence in your project at that point. And that's where you start to use hardware in combination with software. For example, if you wanted to change your blinking LED on a circuit board to blink at a different rate, you'd have to go in and replace a resistor or some component to speed it up. Whereas if you're doing this with a board, you just had to find the line of code, and you probably just change a delay that then makes it blink more quickly. So we call this type of thing where you're connecting electronics to a little computer of some sort. We call this physical computing. So you're starting with a microcontroller board, and perhaps the most famous of these is the Arduino. Who's heard of Arduino? If we could have a show of hands. Okay, so pretty much everybody really. Phenomenally popular, very useful, pretty much bulletproof little board, and a great way to get started with physical computing. So you can add electronics to one of these boards and have the board control the electronics. So you can attach sensors, LED strip lights, relays, all sorts of things. But then the catch is you've then got to write some code that tells the board how to do things with this electronics. So you have to actually program it. And then there's this kind of optional step that a lot of people are looking for in projects, is that they want to make their project work over the internet so that they can connect to a network, and they can turn LEDs on or off, or turn their heating on and off, or do all sorts of other things. Because an awful lot of electronics or an awful lot of projects actually boil down to just turning something on and off. This is kind of an extra step that you might want to take in your projects, and it actually influences to some degree what kind of board you want to use. Because obviously if you want it to work over the internet or a network, you want to choose a board that's got built-in Wi-Fi capabilities, just to make that easier, so you're not adding yet more add-on hardware to your Arduino or whatever you happen to be using. So what boards are available for you to use? Well, one of the really new ones is the BBC Microbit. Again, could I have a show of hands who's come across the BBC Microbit or the Microbit? Few people. Okay. Yeah, it's starting to be used in education, but it's also very usable as a board for makers. These things, I think they cost $15, and it's similar to an Arduino, but you can program it in Python, which is a big plus point for people who are involved in STEM education. So that's the board on the left. Then you have Arduinos, and Arduino now almost describes an infrastructure rather than a particular board. There are just lots of different types of Arduino boards, both official boards and boards that are built as clones, and also boards that are kind of use the same programming environment as the Arduino, but really look absolutely nothing like what the original Arduino boards look. The Particle Photon is a very interesting board. You program it in an Arduino type language, but it has a web-based development environment, and you can deploy new programs to it over the air, which is great if you've got your little Photon board embedded in a project somewhere, all boxed up and maybe even fixed to the wall. So you can reprogram it without actually having to gain physical access to it. You can just send it updates over the air, which is a very neat trick. An extremely low-cost board is the Node MCU, and I think these things are less than $5. They're sort of maybe $3 or $4, I think, in some cases. And these can be programmed as if they were an Arduino. They have their own sort of language as well, but you can kind of flash them and program them from the Arduino development environment. So if you have a lot of mobile sensors, a lot of sensors that you want to set up there, and you need to keep the price of each node down to a minimum, then something like the Node MCU is a good bet for that. Then you get into the bigger boards, the things like the Raspberry Pi and the BeagleBone Black and the BeagleBone Green, the two popular models. And these are really single board computers, so you're kind of in a different territory there. So I'll move on a little to what sort of things you can do with these. So all of those boards we were looking at before can do digital outputs. So you can connect something to a digital output and it'll either turn it on or it'll turn it off. Nothing else. Digital inputs, they'll all do digital inputs, and the typical digital input is a switch. So you press a button, that's a digital input to your board, and then your program can be waiting for that switch press, and it can do something. And the thing it can do might actually just be to use a digital output to turn a light on, or to make a sound, or to do something else. Then you have analog outputs, which can control the amount of power going to something, rather than simply turn it on and off. So if you wanted to dim a light bulb, or dim a light bulb is probably, or control the speed of a motor is another case where you would use an analog output to do that. And then most boards can also do analog inputs, which is where the board can actually read a voltage. So unlike a switch, which is either on or off, an analog input is variable. So you can read the voltage and then make some decision on it. So a typical thing you'd want to do with that is sensors. So you might have a temperature sensor, which gives an output voltage which is proportional to the current temperature that it's reading. And that's the sort of thing you collect to an analog input. The Raspberry Pi actually doesn't have any analog inputs. It's fairly easy to add them to it, but if you're thinking of a project that uses a lot of sensors and you need those sensors to be analog, then you're probably not going to steer away from the Raspberry Pi. So the single board computers, the Raspberry Pi and the BeagleBone, they're much more powerful than any of the other boards I've discussed so far. They are really single board computers. The Raspberry Pi 3 has a quad-core processor. It's a fairly powerful beast. So when you find yourself doing something that, say, needs a big display like one of these, or even just a little display that's very high resolution and you want to display some proper text and things, or you need to do something that's very computationally expensive like computer vision, that takes pictures from a webcam and then actually spots items of interest in that picture, anything like that that uses a lot of processing, then you're going to be looking at a single board computer like the Raspberry Pi or the BeagleBone as the best way of producing your solution, making your project. So where should I start? Which board should I pick to use? In a way, to get started, you want to try and pick things that you already know. Pick things that you already know a bit about, and then you haven't got to start from nothing. So, for example, if you know a bit of the C programming language, textual programming languages, you like something that you can drag and drop to do your programming, then take a look at the microbit and also Scratch on the Raspberry Pi. Scratch is a software system developed by MIT with the express intention of making it very easy for kids to get into coding. So it actually hides away all the nasty syntax of coding, and you drag blocks about. You drag a block on, so if you wanted to turn an LED on, there'll be a block that says turn a digital output on, and then you can say which digital output and whether it should be on or off. So if you like those kind of languages, then the microbit or Raspberry Pi are quite good choices for you, because the Arduinos don't really support that to the same extent. So does it matter which board you pick? Not really, not for getting started. Most of them can do pretty much everything. So if you buy one of them, you can probably kind of shoehorn it into your project and make your project work. But sometimes some boards are more suited to others. So it is rather overkill to actually use a $40 Raspberry Pi to blink an LED on and off. But as a learning exercise, that's fine. And if you've got other things that you want to do with your Pi, then that's still fine. Or if you actually happen to have a Raspberry Pi already, that still makes sense to use it. But for projects that don't require very much computing power or are not doing anything very difficult, then you could probably better starting with an Arduino type board if you haven't already got something. Arduino has analog inputs, which I was mentioning before, for doing sensor-based projects is quite useful. And you can't do any of the computer vision or any of those kind of projects with it. Once you've learned how to use one of these boards, you will find learning how to use the next one very easy. It's a bit like, I think, learning foreign languages. I think once you've learned the first one, it's really hard, but then once you've got the basic concepts, you can pick up the next one much more easily. The Arduino and the Raspberry Pi, between them, are kind of sort of at both ends of each end of the spectrum, and between them they cover pretty much any project you could want to make. So if you want to cover all bases, I'd probably have one of each, just to get me going. So a quick tour of the Arduino. When I say the Arduino, what comes to mind for me, which is the Arduino R3, which is a fairly old design of an Arduino board now, but it's very much the closest thing there is to a standard. And there's a huge number of plug-in shields that will fit on it, with relays and all sorts of different sensors and displays, which will just work out of the box and absolutely fine with the Arduino R3, Uno R3. So I still use this as my standard Arduino, if you like. it has no operating system. It's not like a fully fledged computer. It has a 16 megahertz processor. So this is 16 megahertz. This isn't gigahertz. This is very low computing power. The kind of computing power that you used to find in a home computer in the 1980s or 90s is what you should be thinking of when you're looking at one of these devices. But if you're just controlling LEDs or reading sensors, you probably don't need any more than that. Being able to do 16 million things a second is still pretty fast when you think of it in those terms. Similarly, it doesn't have an awful lot of memory. It only has 2K into which you would keep the data and the variables that you're using while your program is running, and then you have a completely separate 32K of flash memory, which is where the actual program lives, or any data that you don't need to change can live in there as well. It's a very low power device, quite nice and easy to, fairly easy to program. So although it uses a C programming language, it doesn't use any of the nasty bits of the C programming language. It uses, it's all steers away from pointers or anything difficult. So you can really just concentrate on what you're trying to do rather than trying to wrangle the nasty syntax. So this is the Arduino IDE that you have to load on your computer, and then once you have it on your computer, I'll just switch over to the Arduino IDE on here. Okay, so this is the Arduino IDE running on my laptop, and over here I've got an actual Arduino and I've got a USB lead. What I'm going to do is plug the Arduino into my computer. Okay, and it's going to be a little tricky to see, but there is a little, where my finger is, there's a little LED there that you can just see is off at the moment. And what I'm going to do is switch back to my Arduino IDE, and I'm going to tell it to upload this program. Well, that's typical, isn't it? Sorry about that. Usually works perfectly, but demos, ports. Okay, for some reason it's being slow to pick up the serial port. There it is. So, yeah, choose the serial ports, Arduino Uno, and then click on the upload button, and then done uploading. And now if we switch back to the overhead camera, very difficult to see. You can probably just about see that LED blinking on and off. Maybe you just need a bit of imagination. But what we can actually do is add in an external LED. So now we're going to control some real electronics rather than just something that's already on the board. So that built-in flashing LED is actually connected also to pin 13 on the Arduino. So I'll connect pin 13 there and a ground return there. And there we go, now we've got a much bigger LED. So we could just flip back and let's change our program so it will make the LED blink more quickly. Can anybody suggest how I'd do that? Yeah? Change the delay? Okay. Say 200? Yeah? Okay. So at the moment, if we look at our code, it's saying digital write LED digital write 13, and that's pin 13 high. Then delay for 1,000, which is 1,000 milliseconds, so that's 1 second. Then turn it low, and then delay again, and then go back around the loop and keep doing that forever. So if we just go in there and change that to 2, and change that to 2, and then upload the program again, and it says uploading, done uploading, and then if we flip back to the overhead camera, we can see we're blinking much more quickly. And you will find no end of tutorials that will help you get going with this step by step in using an Arduino and actually getting it doing something like this. So let's jump back to the presentation. Okay, a good way to get started with, if you're looking at this, is to buy an Arduino kit. So there's various ones available. There's the official Arduino one from the Arduino... Oh, I'm sorry, thank you. Yeah, there's the official one from the Arduino, the makers of Arduino. Adafruit also have a nice kit called the Ardex Kit. And also, and I have to sort of own up to this, I've also designed a kit for Monk Makes that uses an Arduino compatible device. So that's my little plug there. And this is a picture of the Monk Makes Arduino kit, which actually uses an Arduino compatible device that plugs into solderless breadboard, and it has a little display and things just to help you get going. Sorry? I'm afraid we're not. No, they are available from our website though, so yeah. The Raspberry Pi, few words about this because it is a very important device. So it's a single board computer. It runs a version of Linux called Raspbian. You have to get it started, to get it all set up, you had to attach a keyboard, monitor and mouse, but once you've got it all started, you can actually dispense with them and run it headless. But basically you're still interacting with a computer through a terminal session. It's not a completely standalone thing, rather like the Raspberry Pi. It's still got an operating system on it. And the Raspberry Pi 3 quad-core 1.2 gigahertz processor, plenty of power for doing things like image processing and what have you. So when you're programming the Raspberry Pi to do things like make an LED blink like this, and you could take this hardware and attach it to the pins of a Raspberry Pi very easily, you use the Python programming language is the most common. There are other options available, but there is most support for using Python. But as far as the Raspberry Pi is concerned, it's just another program running on the operating system. So if you've got to generate very precise pulses, say for controlling a servo motor or something, the Raspberry Pi is not very good at that, because every now and then the operating system will interrupt the pulse generation to go and do its own thing. So your servo motor will kind of jitter a bit. It's not great for things like that. There's a nice library for using, for controlling the GPIO pins. This is a new library that's from the Raspberry Pi Foundation, which wraps the old library that people used to use, or still do use, called rpi.gpio, and you can still use that library. But the library GPIO 0 from the Pi Foundation comes pre-installed on the latest versions of Raspbian, and it's a little bit nicer and cleaner to use. Here's a quick example of it. And you can see this is not a million miles away from what we were doing on the Arduino, only now we're doing something like we're saying LED.on rather than digital write. So it's a bit more object oriented for the programmers here. It's kind of a more modern way of doing things. Okay, and there's Raspberry Pi kits. Sorry, second plug, we also have one of them. And also there's a chance to win one. If you go to the Tab DIY stand, which is over in the corner of that big tent over there. Actually, it's on the facing side of the tent next to this big tent. If you put your email address down and name, there's a chance to win the starter kit and a copy of one of my books, if you want to do that. Okay, so very much I would say get yourself a kit, not necessarily one of mine, although obviously that's always appreciated, and just start playing. Just have a go. Come up with a simple project, work through some of the projects in the kit, and then branch out and make your own project. Okay, so I think I've got just a couple of minutes for questions, if anybody's got any. Is that it? Are we done? Okay, well thank you very much everybody. Thanks.